Forget definitions for a few minutes. Let's just watch a real AI model learn something completely from scratch right now and actually understand every step as it happens. Here's the job we're giving it. Guess a house's price using only its size. Nothing else. Simple on purpose. We'll show it 5 real houses. Each one has a size in square feet and a real price in thousands of dollars. Bigger house, higher price, a simple pattern, but the model does not know that yet. Here's the exact data. All 5 houses. 1,000 square feet, $200,000. 1,200 square feet, $230,000. 1,400, $260,000. 1,600, $290,000. 1,800 square feet, $320,000. That's the entire training set. No formulas on screen yet. No jargon at all. Just watch what happens, step by step. At the very start, the model knows absolutely nothing about houses or prices. Its first guess is just a line, drawn with no real information behind it at all. It checks that first guess against the 5 real prices. And right now, it is way off, not even close, for most of these houses. That gap between the guess and the real price is called the error. Right now, the error is large. The whole goal from here is to shrink it. So the model nudges its line a little closer to the real pattern. Just a small step, not a full fix, on purpose. Small, careful steps are safer than big, risky jumps. It checks again, closer this time. Still not quite right, but clearly better than the very first guess. One more round of small adjustments. Now the line is really starting to fit the actual houses, not just guessing near them. And one more round after that. The gaps between the line and the real houses keep getting smaller, round after round. After a few more rounds like that, the line matches the pattern in the data almost perfectly. Nobody told the model this pattern directly. It found it entirely on its own, just by repeating this simple process. Notice something important here. Every single step was small, but small steps, repeated enough times, add up to something that fits the real world extremely well. This repeating loop, guess, check the error, adjust a little, repeat, has a real name. It's one of the most important ideas in all of AI, and we'll open it up properly very soon. Now for the real test. A brand new house, 2,000 square feet. The model has never seen this exact house before, not once, during any of that training. It runs that new number through its fitted line and predicts $350,000. Here's the exact fitted line it found, written out. Price, in thousands, equals 50 plus 0.15 times the size. Plug in 2,000 for size. 50 plus 0.15 times 2,000, which is 300. 50 plus 300 is exactly 350. That's the number, worked by hand, matching the model exactly. And if you actually check the pattern by hand, that prediction lines up exactly with how the other 5 houses behaved. The model generalized. It applied what it learned to something it had never directly seen. That's it. That whole process is what people mean by training. And using the result on something new is what people mean by prediction. You just watched both happen, live, start to finish, with real numbers. On purpose, we didn't explain exactly why the line moved the way it did at each step. That mechanism has real math behind it, and it deserves its own proper explanation. Coming up in this series, 8 real techniques that do exactly this, each in a different way. Then the actual math running underneath all of them. Then a real model you build yourself, understanding every line. Let's check what actually stuck. 3 quick questions. Try to answer each one before the answer appears on screen. Question 1. In this example, what is the model actually adjusting, round after round? The answer is the line. Specifically, it's fit to the 5 real houses. Each round nudges it a little closer to matching the real pattern. Question 2. Using the fitted formula, price equals 50 plus 0.15 times size. What would the model predict for a 2,200 square foot house? The answer is $380,000. 50 plus 0.15 times 2,200, which is 330, gives 380. Question 3. Why does the model take small steps each round, instead of jumping straight to the perfect line immediately? The answer is that small, careful steps are safer than big, risky jumps. Big jumps can overshoot and bounce around instead of settling into the right answer. For now, remember this. A model starts knowing nothing. It checks its guesses against real examples. It adjusts a little at a time. And after enough small steps, It can predict things it has never directly seen. That's what learning actually looks like underneath the buzzwords. Follow AllAboutAIVerse. Let's keep going properly, one honest step at a time.